In this section, we're adding and subtracting radicals. The assignment will be from page 541. 3 through 27, multiples of 3. Now, in the last section, we were multiplying, so you have to shift your mind over to addition rules now. On this, what I want you to be able to identify is like and unlike terms. And to get started with that, example 1 from page 540, you have like terms here. You have 4 times square root of 7 plus 5 times square root of 7. As long as this is exactly the same, you can put your coefficients together. But the square root of 7 will not change. So essentially what this says is I have 4 square roots of 7. Think of it like a variable now. And I'm going to add 5 square roots of 7 to it. It will not change what the square root of 7 is. So if I have 4 here and 5 here, I'm going to have 9 square root of 7 total. And one of the big mistakes I see is people doing 7 plus 7 and making this the square root of 14. So think of it like a variable. You're just adding up the number of variables that you've got. In this case, you're just adding up the number of square roots of 7 that you have. Now, you don't always have just like terms. So let's look at example 2. In the format here, let me just top these off. The software I'm using doesn't complete the square root symbol, so you'll just have to look past that. I'll just write over it as I need to. Make that a little easier. I've got 3 square roots of 6 minus 2 square root of 13. That's a different thing. It's an unlike term, so they can't combine. Plus 5 square root of 6. So combine your two underlined terms to 8 square root of 6 minus 2 square root of 13, and that's as far as you can go. So the main point of that example is to make sure you don't combine unlike terms. Next example is on page 540 as well. Example 3. You've got 7 times the square root of 3 minus 4 times the square root of 6 plus 2 times the square root of 48 minus 6 times the square root of 54. Now the purpose of this example is to show that you have to break down this 48 and this 54 before you can combine any terms. They're not combinable as they sit, but they're not simplified either. So you need to simplify these. Got 48, pulling out perfect roots. Again, I always pull out 4, 9, 16, 25, 36. 16 comes out of this one. 48 is 16 times 3. 54 is 9 times 6. So you're going to take the square root of the 9, multiply it by what's already in front. You're going to take the square root of 16, multiply that by what's already in front. And you're going to be left with a square root of 3 under there and a square root of 6 in place of 54. So here's your next step. 7 square root of 3 minus 4 square root of 6 plus, don't forget to do 4 times 2 to get 8 square root of 3. And then 3 times 6, that's a minus, 18 square root of 6. Alright, now combine like terms. I've got 7 square root of 3 plus 8 square root of 3. Those can be combined. A negative 4 square root of 6 minus 18 more square root of 6. So those can be combined. 7 plus 8 is 15. There's no particular order. You don't have to do the 3's before the 6's. And then negative 4 minus 18 more gives me negative 22 square root of 6. And those cannot be combined. Right? That's your answer. On page 541, when you get down about the middle of the page, you've got a sample problem right before the B section problems. So all of yours that you'll be doing in B will be similar to this. And essentially what you've got to do is rationalize this before you can move on. Remember that square root of 3 over 5 is got an irrational denominator. So what you're going to do with just the second term is multiply by that irrational denominator. So what this becomes, square root of 3 times the square root of 5 is square root of 15. And it's going to be over 5. I'm going to go ahead and bring my first term back down. But I'm going to put it up in a numerator position because I need common denominators to be able to combine these. I need to put this over 5. It's over 1 now. So I'm going to multiply the top and bottom of that fraction by 5, giving me 5 square root of 15 minus the square root of 15 over 5. Now, keep in mind there's a little 1 right there. That means there's 1 square root of 15 right here. So when you combine this across the top, it's essentially 5 minus 1, giving you 4 square root of 15 over 5. I also occasionally see students that want to cancel this 5 with the 15 and make that 3. Keep in mind the square root of 15 is an irrational form underneath the radical sign. 5 is a whole number form. If you converted that 5 into a square root, that would be the square root of 15. I'm sorry, the square root of 25. Not 5. So if you did cancel, you'd have to do it in this format. So you need to stop right here. And hopefully that wasn't too confusing. If you, just to illustrate that, if you had 4 times the square root of 15 over the square root of 25, you could indeed cancel by a factor of 5, and giving you 3 here and giving you 5 here. So you would have 4 times the square root of 3 over the square root of 5. But then you have the problem, you have an irrational number in your denominator again. So you're going to have to multiply by a square root of 5, which would give you 4 times the square root of 15 over 5. So all you did was work in a great big circle. And so make sure you don't go too far there. In the way of problems from the assignments, the ones that I've been asked the most about. Number 18, 4 square root of 12 plus 5 square root of 56 minus 9 square root of 126. Your key again is breaking this down to simplify all of these before you can combine anything. When you do 112, I know 4 will go in there. Let's see what else will happen. 4 goes into 125 times. And it'll go into 12 3 times. Give me 28. 28 is 7 times 4. Now by that, I know I could have pulled a 16 out if I'd wanted to. That would have been 16 times 7, because my prime factorization to roots anyway is 7 times 4 times 4. Well, 4 times 4 is 16. The square root of that is going to be 4. So anytime you get the same number twice, when you factor out one of these radicands, just take that number out. Right, so my first term is 16 square root of 7. Now 56 is 4 times 14. So the square root of 4 is 2. So it's going to be plus 10 square root of 14. 126. Now there's a few different things that come out. I know that a 9 would come out, but that's not always real obvious. If you, let's say you start at 2, I'll show you how this works. You get 2 times 63. At that point you're going to get 9 times 7. So you're going to have 2 times 7 still left underneath your radical sign. The square root of 9 is 3. So I'm going to do minus 3 times 9 is 27, square root of 14. Now in this one, these are the two that can combine since they're both square root of 14. So the answer is 16 square root of 7 minus 17 square root of 14. And on problem number 24, what you need to do here is you need to rationalize each one of these separately. So you got the square root of 2 over square root of 7. This is rationalizing the first term. And rationalizing the second term will involve square root of 2 over square root of 2. Alright, now let's follow this down to see what happens. We got the square root of 14 over 7 minus the square root of 14 over, and square root of 2 times square root of 2 is 2. Now I need a common denominator because I need to be able to subtract these. I think 14 should stand out as the most obvious. So multiply top and bottom of that fraction by 2. Multiply the bottom and top of this fraction by 7. Now my bottom will be 14. On top, I'm going to have 2 square root of 14 minus 7 square root of 14. So that's a negative 5 square root of 14. Remember that that 14 and that 14 cannot cancel. Put this as in the same format as square root of 14, I would have to square this. So that's not the direction I want to go with that. All right, so we are at our answer already. We're done. Got to know when to stop on those. Okay, that's it for section 11.8 and the examples. I'm going to do another quick video on 11.9 followed by 11.10. That's going to be the end of everything from chapter 11. And then we'll move into quadratics after that.